Hi everyone. In this video we're talking about just a few rules that apply whenever you're taking limits. I think this is going to be a pretty straightforward video. So number one, we have the additivity rule for limits. And what this says here is that f of x and g of x are going to be functions. And if I take the limit as x approaches just any number of f of x plus g of x, this is the same thing as taking the limit as x approaches the same number of my function f of x plus my function g of x when I take the same limit, right? And so let me rephrase it and just say that the limit of a sum is the same thing as the sum of two limits. That's what this rule is saying in mathematical notation. And right underneath it is something that goes right along. It's pretty easy to remember. But what this is saying is that whenever I subtract, it works just the same. So the limit of a difference in two functions, or two expressions, that's actually equal to the difference of two limits. And so in other words, you can break a limit up. If you see, a plus sign or a minus sign inside of a limit, you can actually break that into two limits, and maybe that makes it easier to calculate. There's also a product rule for limits, and it goes kind of how you would hope it would. It's pretty easy to remember. Whenever you take the limit of a product of two functions, this is the same thing as a product of the same limit of each of those functions taken individually. And so I could write the same thing if we're taking a limit of a product that's equal to the product of two individual limits. Another way of saying this might be to say you can break up a limit if you see that you're multiplying two or more things inside the limit. You can break it up into two separate limits and multiply those. And this is the same thing. If one of those functions is just a constant, so k is just any constant number, k could be 42, or k could be 7, etc. What this is saying is you can just take any scalar number and just move it out front, right? So you can move k out in front of the limit, and that also makes things easier to take the limit of, right? Now we have a quotient rule for limits, and again, hopefully pretty easy to remember. What this is saying is as long as your denominator is not 0, right? So as long as this does not become 0, because we can't divide by 0, then whenever we take the limit of a quotient of two functions, like in this case we're taking the limit of my function f of x divided by g of x, we can actually just break up the limit right there where we make the division sign. And lastly, we have this power rule for limits, where if I'm raising anything to some power, so I'm using n to represent, some function squared or some function cubed or some function to the fourth power, what I can do is actually just take the limit of that function first and then raise it to the nth power. And so maybe these don't make a whole lot of sense immediately, but what I'm about to do in my next video is work several examples. And maybe once you see some examples of putting these limit rules into practice, you'll see why you might need it.